Chapter 4, Forecasting. The goal of this unit is to understand forecasting, including the three primary time horizons and appropriate models for each. We will understand the use of four quantitative models and how to apply them. We will understand forecast accuracy and the use of regression and correlation analysis. Disney has refined their forecasting skills to cover locations around the globe with short and long-term forecasts. These forecasts are used for staffing, operations, scheduling, and financial planning. Operational plans driven by forecasting include park hours, show scheduling, and staffing. Forecasting at Disney requires an extensive staff executing and analyzing over 1 million surveys a year. A variety of related data points are included, resulting in a forecasting error of less than 3%. This is a very impressive result and shows one reason that Disney is so successful as a business. At the end of this chapter, you should understand the importance of forecasting, be able to use qualitative and quantitative forecasting methods, and measure their accuracy. Finally, you will gain a basic understanding of the use of regression techniques for forecasting. Forecasting is the process of predicting future demand. The goal is to estimate the number of units or dollars sold. Forecasts are used to define production plans, inventory requirements, staffing needs, and facility size. Forecasts are based upon short, medium, and long-range time horizons. Short-range forecasts typically address the effective use of existing resources over the next 3 months. Medium-range forecasts cover sales and production planning, along with budgets for 3 months to 3 years. Finally, long-range forecasts go out past 3 years and address new product plans, facility location, and research activities. For many companies, the introduction of a new product is a key planning activity. The introduction, growth, maturity, and decline of products are known as the product life cycle. Typical products follow a predictable life cycle that will affect staffing, inventory, and capacity. Here's a typical life cycle showing the 4 phases. Various business strategies and issues are listed at the top of each column. We see the product volume curve as it changes over time. The dots on the curve represent a number of products that might be familiar to you. Note that smartwatches and 3D printers are both early in the life cycle. DVDs are on their way out. Here we see a number of operations strategies as they relate to the 4 phases of the product life cycle. During product introduction, things are rather fluid with multiple design changes. Costs are high, and attention must be paid to ensure that the new products and processes have good quality results. As the product matures, forecasts are key. Improvements are made to enhance the product and the production process. Distribution channels are also optimized. With product maturity, things stabilize with a focus on cost control and incremental improvement. Finally, when the product is in decline, further cost control is established as capacity is reduced with the cancellation of poorly performing products. Forecasts drive the end-to-end supply chain, build supplier relationships, and facilitate low cost and reduce time to market. Staffing levels are driven by forecasts. Finally, capacity decisions are driven by forecasts. Inaccurate forecasts can result in supplier and employee uncertainty along with the loss of customers. Here are the typical steps in creating an accurate forecast. Steps 1 through 5 cover the preparation, including clear definition, methods, and data gathering. The actual forecast is performed in step 6, while in step 7, we confirm the results and make use of the data for operations management decision making. Forecasts are estimates and are seldom perfect. Variability may be due to external changes and process instability. By combining or aggregating the forecasting of a product family, the overall forecast will be more accurate than the individual product forecasts. Qualitative methods are used when the situation is fluid and lacks historical data. Here, intuition and expert opinion are used. This is common when wholly new products or processes are being introduced. Quantitative or numerical methods for forecasting are used for stable processes where historical data is available. Different mathematical techniques are applied. A number of common qualitative methods are used. We will discuss each in more detail. A common qualitative method is the jury of executive opinion. Small groups of experts and managers work together to create estimates. This is a quick process but may suffer from groupthink, where individuals are afraid to express differing opinions. The Delphi method is an iterative group process, including respondents who provide the estimates, staff who organize the process, and decision makers who evaluate the estimates and make the final decisions. The process is repeated until consensus is achieved. The Salesforce Composite Qualitative Method collects sales estimates from each salesperson, which are combined to get an aggregate forecast. The salespeople are closest to customer need, but may not provide accurate estimates, as some are optimistic, while others are concerned with easily achieving sales quotas. Finally, market surveys are used to understand customers' future buying plans. Actual sales may vary, and estimates may be optimistic. Now we move to quantitative approaches, including time series models and an associative model. We will discuss each in more detail next. Time series forecasting considers past performance at regular intervals and assumes that past performance will predict future performance. Time series analysis includes trends, cyclical variation, seasonal variation, and random variation. This graph shows the components of demand. We see seasonal peaks that repeat annually along with random variation. The trend line shows an overall increase over time. The components must be understood individually to create an accurate forecast. The trend component defines a long-term persistent change that will generally increase or decrease. This trend may be caused by a number of factors that change over time. Seasonality appears as a regular pattern that repeats itself every year. This pattern may be due to weather or local customs. We see some examples in the table where factors repeat weekly, monthly, and annually. Cyclical variation is similar to seasonal variation as it has a repeating pattern. A major difference is that the change may occur over multiple years and may be due to business cycles or political factors. Random variation is simply that. It's erratic, unpredictable, and unassignable. This is change that is unforeseen but does not repeat and is usually of minimal impact. The naive approach simply assumes that today's demand will be the same as yesterday's. The time period may be any length defined by the forecast. This is where most organizations start. The next step is the use of moving averages. Moving averages are used to smooth demand over time when there is no trend. The moving average is calculated as the sum of the demand in a certain number of periods n divided by the number of periods chosen. Here's an example using moving averages. For April, we take the average of the previous 3 months by using the actual demand for January, February, and March. We repeat the calculation for May using demand data from February, March, and April. We continue the calculation for each subsequent month. A moving average forecast is less sensitive to change, may not identify trends, and requires historical data. This graph demonstrates the issue that moving averages lag growth trends and lead declines. We see this since the forecast for June is noticeably lower than the actual demand, while the opposite is true in November. Exponential smoothing is a weighted moving average, where most recent data has the most impact upon the forecast. We use a smoothing agent, alpha, which ranges from 0 to 1 and is subjective. To calculate a new forecast using exponential smoothing, we need the forecast and actual demand from the previous period, along with the smoothing constant alpha. In this example, the previous forecast was 142 Mustangs, while the actual demand was 153. With a smoothing constant of 0.20, we have everything we need. Plugging the values into the equation, we get a new forecast of approximately 144 Mustangs. Since the smoothing constant is not calculated, we want to understand the impact of our selection of the value for alpha. We usually select an alpha value between 0.05 and 0.5. We can see in the table that as alpha increases, older values have less impact, while recent values drive the result. This graph compares the forecast using different alpha estimates versus the actual demand. Note that a low alpha has smoothed out the forecast, while the higher alpha results in a more responsive forecast. Generally, we choose high alpha values when the demand is likely to change, but lower values with a stable demand. How do we know when we have selected a proper alpha constant? We want to obtain the most accurate forecast. Testing your forecast is typically done by comparing the forecast with the actual demand for a given period. There are three preferred measurements of forecast performance, but we will focus on the mean absolute deviation, or MAD. To calculate the MAD, we take the sum of the absolute value of the difference between the actual demand and the forecast. The sum is divided by the number of periods considered. We start by calculating the quarterly forecast with alpha values of 0.1 and 0.5. In the third column, we show the actual calculations, while the fourth column simply shows the results of the calculations. We also see the actual demand for each quarter in tons. We take the data from the previous table and add the absolute deviation calculation for each quarter for the two alpha values. Remember that the absolute deviation is the absolute value of the difference between the forecast and the actual demand. We sum each column to get 82.45 for the first and 98.62 for the second alpha value. Dividing by the number of periods considered, 8, we get the MAD values of 10.31 and 12.33. Comparing the two MAD values, we see that for this specific set of data, an alpha value of 0.10 gives us the better forecast, resulting in less deviation. We recall from our earlier discussion, trends follow a straight line and are used to project medium to long-range changes in demand. Since the trend follows a straight line, we start by understanding the formula for a line, which is shown here. The dependent variable to be predicted equals the sum of the y-axis intercept and the product of the independent variable and the slope of the line. The least squares method starts with the trend line as defined in the previous slide. For each value of the time period, the independent variable, we find the difference between the actual demand and the value forecast by the trend line. For each value, we calculate the square of the deviation. This table shows the application of the least squares method. We start with the demand for electric power over 7 years. The blue line reflects the actual values from the first table. Based on the actual values, we find a forecast as shown by the red line. Since the equation of the forecast is known, we can plug in the time period and predict the future forecast for that time period. Associative forecasting uses predictor variables and uses the least squares technique. We start with the equation for our trend line. Computer models are used to calculate multiple regression forecasts. This approach is used when multiple independent variables contribute to the outcome. The basic equation for a trend based upon multiple variables is shown here. Correlation reflects the strength of the relationship between the variables. The coefficient of correlation measures the strength of the relationship and ranges from -1 to +1. It is important to note that correlation does not imply causality. Correlation suggests that the two variables have similar trends, while causality means that one causes the other. For example, there is a strong correlation between ice cream sales and bicycle sales since they both tend to occur in the summer. However, increased ice cream sales do not cause an increase in bicycle sales. This is one of the flaws with correlation. These graphs show typical data patterns for different levels of correlation. Negative correlation causes an inverse relationship between the variables. One goes up as the other goes down. At zero, there is no apparent pattern, while positive coefficients result in a positive correlation, where one goes up if the other goes up. A perfect correlation exists when the data points fall on a straight line. Look at each of the smaller graphs to understand the patterns. Forecasting services can be a challenge. Forecasting methods vary greatly among service industries and are affected by holidays and unplanned events. This graph shows the call volume at the call center for FedEx. Note that most calls fall during the day and evening. This forecast may be used to plan staffing levels and hours, along with scheduled downtime for supporting systems. There is a strong connection between marketing and forecasting. Initial forecasts, when limited actual data exist, are usually provided by marketing. The forecast links marketing with the other operations within the organization. The marketing team can manage demand through advertising and promotions and by recommending the creation of new products. For management, forecasts are used for staffing and strategies. Initiatives may be established to manage future demand. Forecasts are also used to identify future concerns so that proactive steps may be taken before a crisis occurs. Financial statements for a company include future forecasts. Forecasts are used to define future funding requirements and areas calling for expansion. Forecasts define the source of future funding and provide stability to the firm by minimizing fire drills. Forecasting is an integral part of operations management. All planning activities require the effective use of different forecasting tools and methods based upon their assumptions and limitations. Ultimately, accurate forecasts will improve company performance in a number of ways. The end result will be increased customer satisfaction and company stability with an improved financial position. Strong forecasting will also lead the company into the future.